Good evening friends, I hope you are following the thermodynamic lectures. We are completed different types of process. The first process we are completed, that is the isobaric process we are completed. Now the second process we are entering, that process is the isochoric process. What does it mean by isochoric process? Isochoric process means in a process the volume of the system must be maintained as a constant. That process is named as the isochoric process. That means in this process volume is a constant. So when the system must be maintained, a volume is a constant means the walls of the cylinder must be maintained as a non-movable piston we will provide. That means the walls or the piston must be rigid, the cylinder walls must be rigid. So now I am writing here the walls are rigid or it is a fixed walls, it is a rigid or fixed walls. Then only we can say that the volume of the system, the volume of the ideal gas is maintained at constant volume. Now as we know the volume of the system is constant, which law will obey for the ideal gas? We already known the Galileo's law will obey hold good, or the Galileo's law obeys. That means the equation of state of the thermodynamic system is nothing but it is the Galileo's law. What is the Galileo's law? We are recalling this one. So it obeys Galileo's law. Galileo's law. What is the Galileo's law? Galileo's law is saying that so the pressure of the gas is directly proportional to the absolute temperature of the system, absolute temperature of the gas. This is the Galileo's law. Then we will say that the equation of state of the thermodynamic system is equal to P is directly proportional to T. Therefore the equation of state of thermodynamic system for isochoric process is, what is the law? P is directly proportional to T. So then with help of this P is directly proportional to T, so we will write a constant. So P is directly proportional to T, then by removing the proportionality we will need to keep some constant or proportionality constant. P some constant into T, then P by T is equal to some constant will be generated here. So then what we can write with help of the ideal gas equation, I am defining this, what is the constant value here. So with what is the ideal gas equation? PV is equal to nRT formula is there, then P by T we needed, I am sending this T this side, I am sending this V this side, then P by T is equal to nR divided by T. This is the formula we are having, nR divided by V, nR divided by V, this formula I am getting. So that means the P by T is equal to, that constant is equal to nR divided by V. This is the formula in the isochoric process. Now we need to draw a different type of graphs. Now let me start with the first graph. So I am going to draw a graphs. So what is the values we are having? We have the pressure, volume, temperature, but in our process is the isochoric process is there. That means volume of the system is maintained at constant. Now we are going, first graph is equal to PV graph, P comma V graph I am going to graph. So P comma V graph means as volume of the gas is equal to constant, we can take the, if we take the pressure in the y axis and volume is the volume in x axis, there are the two types of graphs we can draw here, because of at constant volume the pressure of the system can be increase the pressure, the pressure of the system can be decreases due to, if I supply the temperature, if I supply the heat energy to the system, the pressure must be increases. If I release the temperature if I taken the energy, heat energy from the system, then the temperature will decreases, then the pressure of the system must be decreases due to the kinetic energy will increases as depending upon the temperature of the system, due to the collisions must be increases. That is the thing. Now we can have the two graphs. If the pressure is increases at constant volume, this is the increasing pressure graph. If the pressure is decreases at constant volume, it is the decreasing pressure graph. Now with help of these graphs, what is the slope of these graphs for the PV graph? Now even it is increasing, even it is decreasing, the slope is equal to, so the variation in the y parameter divided by variation in the x parameter. Here is the variation in the y parameter is equal to some value is there, that we will get the dp value we get, but variation in the x parameter, x value is the volume that is not varying, that is equal to dv. But I am taking the value of dp divided by variation value is equal to 0, then some value divided by 0 is equal to infinity. This is the very important. So the slope in isochoric process in PV graph is equal to infinity. This is a very important, slope is infinity. Now let me go to the another graph. Now the second graph I am going to draw. Just now we drawn the PV graph, now I am going to draw a PT graph. So PT graph means let me take the P and T, what are the relation is there in the isochoric process. Isochoric process is equal to P is directly proportional to T. From this equation, P is equal to some constant into T is there. So the constant we already defined, what is that value, NR divided by V into some constant is some T is there, that is equal to E. If we take the P in y axis, if we take the T in x axis, that is equal to some M value we are getting, y is equal to mx graph we are getting. There is no any C value with this one, that means the graph will provide the straight line which is passing through the origin. Now let me draw a graph by taking the, in x coordinate system I am taking the temperature, in y coordinate system I am taking the pressure in the y coordinate system. Now if we draw a graph, this is equal to y is equal to mx graph will there, here is the equal to P is equal to some directly proportional to T. What is the slope of the graph here? This is the slope of the graph, that is equal to slope is equal to variation in y value divided by variation is x value. Here is the variation in pressure value divided by variation in temperature, that value is equal to, this value is equal to nRT, nr divided by V, nr divided by V, or we can write simply divided by P by T is equal to nr by, just send this side is equal to P by T is equal to nr by V, that is equal to slope of the graph in PT graph. I hope you understand about this PT graph. Now let me go to the another graph, third graph. So the third graph is equal to VT graph. I am taking VT graph. So VT graph means what is the, as this process is the volume is a constant process, then if we take the temperature in x axis and volume is the y axis, temperature in x axis, volume in the y axis, as the even you are increasing the temperature, the volume is maintained at constant volume, then this is the initial temperature Ta, it is the final temperature Tf. Then what is the slope of this graph? Then slope is equal to variation in y value divided by variation in x value. Here is the variation in y value dv divided by variation in x value t, but here is the variation in y value is equal to 0, then variation is equal to total slope is equal to 0. The slope of this VT graph in isochoric process is 0. Now let me go to the, what is the work done in this process. Now let me go to the work done in isochoric process. So what is the definition for the work done? Work done, we are having work done is equal to integral of P into dV is there. This is the formula we are having. but with help of this one, that pressure is not a constant in this one, we need to. So, as this formula we are getting, we have the two formulas for this one. Work done dW is equal to, one more formula is there, work done, this one is equal to integral of dW is equal to is there, integral of P into dV, this formula we are having. So, now work done dW is equal to P into dV is there. With help of this formula, P into variation of volume is equal to V final value minus V initial value. But as the volume is not varying, that is why this in this process the work done is equal to completely 0, there is no any work done. Now, with help of first law, what about the first law of thermodynamics in isochoric process? What happened about the, what is any modification in the first law of thermodynamics? If we go to the first law of thermodynamics in isochoric process, what happened the first law of thermodynamics in isochoric process, or we are going to investigate, that is equal to, once again recalling this first law of thermodynamics, the amount of heat supplied to the system is equal to the change in internal energy and external work done, but in our case the dW value is equal to 0, as we discussed in the just before. Now, that is equal to dQ is equal to du. So, as this process is running with at constant volume is equal to constant, then du have the one of the important formula, NCV into dt formula is there. Then, so, and we can conclude here the one of the small definition here. So, the dq is equal to du means if dq is equal to positive, du must be positive. That means dq is equal to positive means if we are supplying the heat energy to the system, then the internal energy of the system must be increases. If we are removing the heat energy from the system, means it is a negative. So, if you are removing negative means the du also will be negative, that is equal to the temperature of the the temperature of the system will be decreases, that is also the internal energy of the system must be decreases. This is the formula we are having. Now, with help, as we are following the constant volume of the system, then the dq can be written as with help of this formula. I am modifying this one, dq is equal to n into Cv into delta T. So, this formula I am using. So, we are very familiar with Cv formula in terms of gamma formula is there, that is equal to Cv is equal to, what is the formula we are having, R divided by gamma minus 1, we are having the formula. Then dq is equal to, what is the formula we are having, NCV into delta T is there. Just to substitute above value of the Cv value divided by gamma minus 1 into dt, this is the formula we are having. Just I substituted this value, this Cv value in this equation. Then what will happen, n into R into dt divided by gamma minus 1. What does it mean by dt? The variation of the temperature, that is equal to final temperature minus initial temperature. Just to substitute that value, that is equal to, just I am substituting in this term, dt is equal to nr into dt is equal to T final value minus T initial value divided by gamma minus 1. That is equal to nr into T final minus nr into T initial. T initial I am writing outside gamma minus 1. This is the bracket I am taking. Once again I am recalling the ideal gas equation, that is equal to PV is equal to nRT is the formula is there, that is equal to P initial V initial is equal to nR into T initial, we will get P final V final, that is equal to nR into T final we will get. But in our case, as V is equal to constant, then we can write it as the P initial V is equal to constant, nR into T initial we will get. In our case, P final V is the constant, that is equal to, that this formula I am modifying, that is equal to nR into T final we will get. So, just I am substituting in the above equation. If you subtract these two equation, that is equal to P initial V initial minus P final V final is equal to nR into T final minus, sorry, I need to put here final values, here is the initial value. Just to modify, let me rub this one, again I will write. Okay, now so now I am taking P final V final minus P initial V initial I am taking, that is equal to just NR T final minus NR into T initial we will get. But in our case volume is the constant, I am taking volume is the outside, that is equal to PF minus Pi is equal to NR into T final minus T initial we are getting, that is equal to NR into dt we are getting, that is equal to V into dP we are getting. So this value is equal to V into dP. Now just to substitute this equation, in this value we are getting NR T final minus T initial, that is equal to NR dt we are getting, 1 minus gamma is there, that is equal to 1 by gamma minus 1 into what is the value we are getting, so V into dP. So now here we are getting V into dP instead of V into dP, that is equal to V into dP is equal to P final minus P initial we are getting. So once again I am writing the complete formula here. So the complete formula is equal to dq is equal to 1 by gamma minus 1 bracket open V into P final minus P initial. This is the formula we are having. So simply we can write it as the gamma minus 1 into V into dP as a simpler equation, short form of this equation. Like this, the first law of thermodynamics is modifying in this equation. So once again our conclusion is most important in this equation. What is saying that if isochoric process, the amount of heat supplied to the system is utilized only to raise the internal energy of the system, to increase, it is utilized only to increase the internal energy of the system, or if we extract the energy from the heat energy from the system, it will only, the temperature of the internal energy of the system will be decreases. That is the most important conclusion in the isochoric process. And also how the first law of thermodynamics is modifying also very important, we are going to use to solve the problems. Thank you.